First of all, yeah, good morning, everyone. Hope everyone is doing great. Hope you are able to see my screen as well. Can someone confirm if you're able to see the screen?
Yes, we can see.
Okay, cool. Okay, yeah. So today's session is about the Google search system design. Basically, predominantly, we'll be talking about crawling and the indexing, right? So yeah, searching is very hard, right? So it's a hard component to design. So, but we'll try to discuss certain basic fundamentals around Google search in predominantly crawling and indexing, right? Yeah, so myself, Sharath, so I'm a technical leader and I have like overall 16 plus years of experience in the IT field. So currently I'm working with Microsoft as an engineering manager, working for their Windows engineering team, right? So where we kind of add new functionality to the Windows ecosystem, right? So prior to Microsoft, I have worked on various organizations like Bank of America, Sony, and etc. Right? So where I worked as a technical lead, solution architect, and a software engineering manager as well. Yeah, so that's a brief about myself. And yeah, so what is today's agenda? We'll discuss about the distributed search, right? How to implement a distributed search, right? Maybe in the interest of time, we'll be focusing more on the crawling and the indexing aspects, right? And also we'll talk about the overall search. What is the search? What exactly we need to do? What are the products available in the market, right? And also we'll talk about the functional and non-functional aspects and our designer approach. Okay, so that's the agenda for today's call. And stop me if you have any questions. All right, I'm happy to kind of answer it. Okay, fine. So what search, right? I think everyone is aware, right? So we know great products like Google, Bing, Yahoo search are already there in the market for the search functionality or the web search, right? And everyone expects search to be there almost in, it's like a today's DNA, right? The search is important functionality in any of our applications or any of our web portal. The search is expected to be there, right? So we have various products in the market as well, right? So one of the prominent or more popular such products are like there are certain open source related products like Lucene, Solar, Apache Solar, ELK, Elasticsearch, right? Like, and also the cloud offerings like Azure Search, Google's Cloud Search, and various other tools and the products available in the market, right? So our intent here was to understand how this search has been implemented, right? Or what is the basics of implementing these search systems, right? And also how it has been scaled, right? Example, the Google story is like the story of scaling up, right? So they're, as you know, the scale which Google supports is huge, right? So they support millions of customers and millions of users who are accessing their Google search product. Like how are they doing it, right? How Google search works. At a high level, maybe we can cover on those aspects as well. Okay, right? Yeah, so stop me if you have any questions, right? Okay. So this is the overall system design or overall high-level component diagram of any search engine. Okay, it's not just for Google, any search engine. This is what generally at a high level, if you look at, right, this is how it will look like. Okay, so predominantly, so you have three important components on any search application. First is the crawler, right? So what does this crawler will do? Basically, the crawler will go to all the websites in the world, right? Or any other data sources in the world where we need to consider for search, right? So the crawler will first component of the first aspect of crawler is it will go to all the websites, get all the content, right? So that's the important intent of the crawler. So once we crawl or once we scrape the content from various websites or various data sources, what we do is we give it to the indexer. What the indexer do here is, based on the data which we have scraped or based on the data which we have identified from various websites, right? So we kind of normalize that data, or we basically get a metadata about that web pages, right? And store the normalized data in our internal database, right? Which we call it as a metadata. Okay. Example, let's say there is a web page which has a lot of text in that, right? So let's say there's a text called hello, how are you, right? That's the message is there in that web page, right? So what the crawler will be doing, crawler is accessing that particular web page which has hello, how are you, right? And that information is being sent to the indexer. What the indexer will be doing it, indexer will be storing the metadata about that page, right? The metadata about that page is like, hey, the website name is abc.com, right? So that's the metadata, the URI of the metadata, right? And also when we are able to scroll, what is the time frame when we have accessed this particular web page, right? So that is a kind of a metadata. And the content of that text, right? That what is the content? We have three words: hello, how are you, right? Or four words basically, right? So what we'll be doing is we'll be storing the keywords in our metadata. Hey, hello, how are you? These are the four words, right? So these four words are available in so and so web page, right? So that kind of information is being stored in the metadata, right? It's a kind of an indexing, right? Again, we'll go in detail, but the indexer is the guy who will be scraping all the text available in the website, and it will be storing or it will be indexing in our metadata, right? So now based on that metadata which is available, we will be executing certain query or the search logic, right? This is what the actor is, the customer like you and me, who will be leveraging or using some of the UI components, right? Like, which is nothing but the google.com, where you search for a keyword and we get the information, right? Example, if you search for a hello, what we do is we query against this metadata. Now we know that, hey, hello is a keyword which is available on a page called abc.com, right? So that abc.com will be sent back to the customer, right? Okay. So that's the third important component, which is querying or retrieving the data from our metadata. Okay. Of course, on top of that, there are certain sophisticated algorithms called ranking, right? Like rank. There are a lot of web pages in the world, right? Which web page I need to show in the top? Okay. Or those that's something called ranking, right? So the ranking works on various aspects. The freshness of the web page. If there are two pages, let's say abc.com and xyz.com, both are having the same message called hello, how are you, right? So which web page I need to show first? Maybe fresh based on the freshness of the page. If abc.com has been refreshed or has been updated recently, we need to show abc in the top. After that, xyz, right? So that's the kind of a ranking algorithm, or the number of words, right? A lot of permutations and combinations are involved in identifying the ranking about a particular web page. Okay, so yeah, in short, any search application, so these are the three important components: crawler, indexer, and query, are the searcher, right? So these are the important components of even the Google search as well. Okay, is there any question? Yeah, so stop me if you have any question as well, but this is a high level component diagram of our distributed search or any other search application. Okay, so we'll do a comparison. This fundamentals, right? Whatever we talked about, right? We talked the fundamentals are like fundamentals for any search engine is crawler, indexer, and query, right? So we will do a comparison with one of our open source search product, which is Elasticsearch. right? So most of you might have aware of this search. If not, I'll just give a high level overview about what exactly is this Elasticsearch or the ELK stack, right? So basically it is not search, sorry. This is a ELK stack. Okay, what is this ELK? ELK stands for, I mean, it has three products basically. First E stands for Elastic. Second, L stands for a log stack, right? And K stands for Kiban, right? So we will keep Kibana, right? So we'll kind of talk about these three products in detail, right? So what exactly these products are and how it is related to our core component of a search, which we kind of discussed just now. Okay. Any questions so far? Okay, fine. So yeah, if you are not speaking, please be on mute. So because how crawler starts, possibly crawler already processed the page. Yeah, we'll talk about that. So our intent of this agenda, our intent of this meeting was to talk about what is crawler, how it works, and what is indexer, how it works, right? So we'll talk about that. But here I'm just kind of giving an overview about what are the important components of a search engine or any other search component like Google. Okay, we'll talk in detail about crawler. Okay. So yeah, so now coming back, hey, there are a lot of products in the market, right? Uh, like ELK, right? Azure search, cloud offerings like Azure search, cloud search from Google, and AWS do have some search option, which I don't have top of my mind, right? Okay, so how the search components are implemented? Okay, so we will leverage, since Elasticsearch is a kind of an open source, we got a liberty or we got an opportunity to look at the architecture about this Elasticsearch. Okay, as mentioned, the Elasticsearch has these components, right? These are the set of components which we have under Elasticsearch. Okay, right. So these are the list of components in the Elastic stack. Okay, okay. So first component is before that, what is an Elasticsearch? So Elasticsearch is a distributed, RESTful search and analytical engine capable of addressing the growing number of use cases specific to the search. Okay, yeah. So what are the various components which we have in our Elasticsearch, right? Maybe I'll go to the drawing board and we'll talk about these aspects, right? So one of the important component within the ELK, which is Elastic ELK stack, log stack, and various other components, right? ELK stack. One of the important component we have is log stack. Log stacks, right? What is this, right? So this is a component which has been provided by the ELK, what you call ELK stack, right? What this guy is doing is this guy is acting as a crawler for us. Or basically, it is acting as a guy who will fetch the information. Okay, data aggregation and processing. Okay, fine. So what does it mean, right? So let's say you want to implement some kind of a searching functionality in your organization. Okay, so let's say you're working for an organization called X, right? And your management or your business have asked, hey, we want to enable a search functionality, right? So that the search will query against all our intranet pages, all our HR pages, all our some other corporate specific web pages. Okay, got it? So the business ask is, hey, we have certain HR specific web pages, right? Or some files, okay? And also you have a certain intranet, maybe some documentation around your product or your teams and all that, right? So intranet, okay? Let's say it could be a SharePoint or any other thing, kind of a thing, right? You have an intranet or some wiki pages or some SharePoint or some kind of a discovery portal, right? Something like that, right? Which you are using it for documenting about your product, documenting about your teams, documenting about your company. Okay, right? So there are various sites or various pages within your organization, right? And also you have certain databases like employee details, something like that, right? So these are the various web pages or various things within your organization. So this is your organization. Your organization is having a lot of web pages, lot of content, everything has been there, right? So your business team came and saying that, hey, we want to implement some kind of a search functionality so that our employees can access all these pages in a right way. Okay. So you to make it faster, to implement this faster, you have adopted or you have leveraged this open source stack called ELK. Okay, Elastic, Log Stack, and Kibana. Right. So those are the three components. What is this log stack will do is that this log stack basically it will kind of aggregate all the information into a centralized place. Okay, so this is the guy who is responsible to kind of get the information from various data stores. Okay, right? Am I making sense so far? Right. So the log stack, what this guy will be doing is this guy is acting as a kind of a crawler for us, right? So basically, it is aggregating all the data from various places, right? So there is one more component within the ELK which is called beats, right? What is that beats is? This is one more small component, right? Which has been provided. Let's say there is something called a beat. You will be implementing some kind of a agent. Okay. Okay. What this beat will be doing is this is an agent which is deployed on this particular area, right? What it does is this beat is nothing but file beat. It will read all the files and the data of the files is being sent to Logstack. Okay, right? Okay, that's one kind of a thing, right? Or let's say we want to know all the details about your employee Windows logs. Okay, like when the employee has logged in, how many times the employee has used the application or his monitor and all that things, right? I mean, his desktop, right? Basically, what we will be doing is we will be installing some kind of an agent at this particular level, which is like a window beat. Okay, basically it is getting all the informations from your Windows operating systems, assuming all your employees are using the Windows as their operating system on their workstations. Okay, what this guy will be doing, this guy, okay, will collect, this agent will collect all the information specific to the Windows and give it to the Logstack, right? And you have one more component called intranet, like a SharePoint or some kind of a web application where you are documenting about your product, right? So what we'll be doing, we maybe directly via the beat or directly we are kind of getting all the information from the intranet into the Logstack. Okay, so predominantly this is acting as a crawler. It is getting all the information from various data sources, right? And it is kind of aggregating all this information. Okay, so that's what we kind of talked about Logstack, right? Data aggregation and processing. So once the data has been aggregated, we have another component called Elasticsearch. This is acting, this is kind of indexing it, right? What is indexing? Basically, the indexing is nothing but it's a kind of a mechanism where you are trying to make search faster. Okay, so predominantly indexing is nothing but providing a capability of random access. I can directly, if someone want to search for a particular module or a particular text, he can directly navigate to that particular page itself, right? It's just like in our book, right? We have an index page. So if you want to go to the conclusion, maybe you can go to the index page and you can see where is the conclusion page. Maybe you can, it will have the page number, directly can go to the conclusion page. On the same lines, if someone is searching, we want to understand if someone is searching for a conclusion, we want to maintain a kind of index page or an index table so that we know where to go to show the results, right? So that's the indexing aspect, right? So the indexing has been taken care by this Elasticsearch component. Okay. Fine. We kind of talked about two components. One is crawler. So the crawler has been implemented by the log stack in this case, and indexing and the storage has been taken care by the Elastic. One more component which we talked about, the indexer. Okay. And the last component is Kibana, right? So basically, if now you have the data, right? So now you have the data. So via the log stack, you are able to aggregate the information, and the Elasticsearch, you are able to index the data and you are able to store it in your kind of a local meta store or local data store, right? So the next step is you need to kind of query, correct? You need to query against your metadata so that you know, hey, if someone is searching for a particular text, we know where that page is, right? If someone says that, hey, I want to search for Expertifie, okay, this is a keyword, right? Maybe this keyword is available somewhere in a intranet page or some wiki page. This keyword is available, so we'll be showing that results, right? So basically Kibana is nothing but it's a kind of a visualization screen where you can use this to search, okay, right? Or you can customize as well, the customize the look and feel, as well as you can know the trends. What are the trends, right? Hey, which search is more trending, right? Where people are searching for, all those things will be kind of available on Kibana, right? So this is again coming back to our core concepts which we are talked about search, which is crawling. This guy is acting as a crawling, aggregating the information from various data sources. This guy is acting as an indexer. It is kind of normalizing the data so that the search can be faster. And this guy is acting as a query, right? This guy is able to query against our database and get the results, right? So this all goes back to the core component of crawling, indexer, and query, right? So what I'm trying to convey here is we are trying to say that these are the important building blocks, right? All these search products are using the same concepts, okay? And this is the proof which we are showing to you guys, right? So our open source product like the Elk Stack is leveraging the same concepts, right? So the log stack is acting as a crawler, this is acting as an indexer, and this is acting as a querying or a tool where you can see the search results. Okay, I'll stop here to see if there are any questions. Elasticsearch is same as, I think this is a separate product, Muhammad. I think various products. I am not very sure whether Angelica search, I mean, this search is open source or it's a enterprise product, right? But I'm sure the same, this is being using the same concepts as what we have discussed. How to restrict the sensitive information? Yeah, very good point. We'll talk about that as a part of our crawling mechanism, Shankar. Okay. Any other questions? Can you explain the Elasticsearch topic? When you say Elasticsearch, do you mean the indexing part, Shankara? If yes, if you are looking out more on the indexing part, yeah, just give a minute. Maybe in the next slides, we'll talk about. I lost some points. Okay, maybe Shankar, maybe you can unmute and ask your question so that I can try to help you what exactly you are looking out for. If not, maybe you can hold on for a couple of minutes. I'll repeat the same concepts again when we're talking about indexing and the crawling functionality. Okay, cool. Yeah, so we will kind of talk about the crawling and indexing functionality next. Okay. So I think by now you are able to understand what is crawling, right? Basically, it's like going accessing various websites in the world, right? And kind of store the metadata about these websites in our internal databases so that things will be faster. Okay. So yeah, so we know crawling is a web crawler is an important or crawling is an important component. So now let's talk about how to design the web crawler, right? Let's say your business says that, hey, we want to implement this distributed search, right? So as you know, the first important component in the search is crawler. So let's design the web crawler. Okay, this is the requirement. So what is the functional requirement? The crawling. The system should show that I mean the internet, the entire uh, www, right? Like the entire internet, right? As spanning from the queue of seed URLs provided initially by system administrator. What does it mean is, in this use case, which we kind of talked about, right? In the use case which we kind of talked about, right? So what your product owner has asked, hey, crawl the information from our HR web page, our intranet, our employee windows, right? Maybe in future they'll say that, hey, expand this for the Stack Overflow as well, right? Some kind of a Stack Overflow, right? Or let's say some kind of a MSDN, right? So that your internal employees can search on any technical issues, right? And they can see that on the within our portal, okay? Or they can say that, hey, also include Twitter, right? Because people kind of talk about technical issues on Twitter as well, right? Okay, so basically these are nothing but the data sources which your business is saying. Okay, so we kind of treat this as a seed URLs, right? This is nothing but a seed, right? How the tree can grow based on by considering this a seed, right? So these are nothing but the seed URLs. Okay, right? So whereas in a Google's case, the Google's search case, the seed URLs is the entire internet. Okay, right? Now coming back to our functional requirement, what the requirement, it says that, hey, the scope for you was the entire internet. Okay, all right, but in the internet as well there are billions of URLs. Maybe I don't require to consider all the URLs, right? Maybe a 60% or some set of URLs is what we need to consider, right? That's what the requirement says that. So you need to build a crawling system which can access all these URLs, right? Get the information and store it in our database for search purpose. Okay, so that's the requirement number one. Storing, right? The system should be able to extract and store the content of the URL in a blob store. What it is saying, hey, you are accessing some particular website, let's say ndtv.com, that's a news website, right? There is a lot of content in that. We need to extract that content and store it in our internal database so that someone queries against our portal, we can retrieve the information from ndtv.com. Okay, right? On top of that, you need to apply certain ranking, indexing, and other concepts so that things will be faster. I mean, indexing for faster, ranking for showing the appropriate content to the customer. Okay, fine. And the other requirement is scheduling. What the people are saying is, hey, NDTV kind of updates their news content on a regular basis. So you should have a capability to kind of recall again and again. Maybe at 10 o'clock, you're crawling the NDTV and getting the results. Maybe again on 10:02, again, you need to crawl the NDTV and get the latest results, right? So that's the kind of a functional requirement which your business has shared with you. Okay, right? So now based on this requirement, what you have understand is I need to crawl the entire internet, right? Which means that our application should be scalable enough. It is a scalability requirement. The scale is huge, right? We're talking a system like a Google, right? So where the scalable ask is very high, right? So the non-functional requirement are the architectural characteristic which we have identified is scalability. So I need to build a system which is scalable or which supports scaling. Today, this is supporting to scroll against all the internet pages, but tomorrow it might add capabilities like some, let's say, some intranet, some other HTML, some HR web pages, kind of a thing, right? So scalability is one of our important requirement which we have identified. Next is extensibility. So when I'm having a discussion with my, what you call, the product owners or the business guys, so they mentioned that, hey, Initially, our requirement was to text. You need to scroll the text, but in future, we need to support search of images, right? Maybe if someone search Expertify, right, we need to show the Expertify logo as well on the image section. Basically, we need to extend this web crawling functionality not only for text, also on the multimedia scenarios like images, videos, voice, etc. Okay, right? This is the one of the non-functional requirement which I understood based after talking to my business owners. Okay, next is consistency. What is a consistency meaning? If I'm crawling, if I'm getting the information from a particular portal, right? Let's say there you are kind of accessing, you as end user are accessing a website, right? Let's say ndtv.com only, right? So whatever the information you're seeing on the ndtv.com, the same information need to be available in our search metadata as well, right? It should be consistent. It should not be like, hey, user A is looking something on ndtv.com, but we are showing something different on in our metadata, right? That it should not be there. It should be consistent. The experience should be consistent across our system. So that's one of the non-functional requirement. And the last one is performance, right? So we need to get a real-time data, right? So the NDTV is an example. It's a news website where the news gets uh, updated very frequently, right? So we need to ensure our system is capable enough to get the near real-time data in our metadata as well. Okay, so this is what the functional requirement which I have which I have identified after talking to my business about the functional requirements. Okay, I'll stop here to see if there are any questions for you. Okay, fine. So now what I have, okay, right, I'll use this notepad as our rough notes. Okay, so now what we have the functional requirement, right? And we have identified the non-functional requirements, right? And you might have some the architectural principles or decisions, right? The architectural principles or decisions could be, hey, always use APIs for your communication. Okay, meaning whenever you are interacting within your organization, always ensure the interaction is happening via APIs, right? Or implement some kind of a decoupled system. Okay, meaning don't implement or think about modernizing our architecture, right? So certain decisions and principles your organization or your team might have kind of considered, right? Okay. So based on the functional requirements and non-functional requirements and the principles and the decisions, you need to identify the architectural style. Okay. What is the architectural style? Hey, what is the architecture I need to use? Whether I need to use monolithic architecture, right? Or whether I need to use some kind of a microservice architecture, right? Or I need to use service-oriented architecture, or I need to use plug-and-play architecture. What kind of an architecture I need to use in order to design this particular application? So this is my kind of a requirement. Right? So I need to identify the architectural style based on these three aspects. So what I have done, I have identified functional requirement. I have identified non-functional requirement. Next is I have certain principles and decisions. The principles could be, hey, always use APIs, right? Whenever required, use asynchronous mechanism, right? Okay. Or it could be like a always implement your design which is cloud ready. Maybe initially you're not thinking about cloud, but future you might want to go to cloud. So design your system using the cloud ready principles, right? So these are the decisions and principles which you are considering. Okay. Okay. So before making an architectural style, before kind of concluding what is the best architectural style, right? Maybe we need to think on the capacity as well. What we are talking about, how much of capacity we need, what is the data stored, right? What is our time, what is the performance here we're talking about, right? We need to spend some time on that. Okay, right? Storage. What we discussed is the crawling. What it will do, it will crawl the web page like ndtv.com. It will identify or it will fetch all the news and it will store in our metadata. Okay. Basically, we are storing the web page content in our database, right? So which means that I need to plan the capacity for my storage. Okay. So the assumption here is there may be around 5 billion web pages in the world, since our requirement was the entire internet, entire www, right? So our assumption is there are around 5 billion web pages in the world. Okay. Each web page might have around 2000 kb, right? Based on certain analysis, I have identified that on average each web page has, I'm talking about only text, I'm not considering the images or any multimedia like video on the web page, right? Only on the text. On an average, right, it is around 2070 or 2000 kb. Apart from that actual content of the text, I need to store certain metadata about the web page. What is the URL of that web page? When this web page has been refreshed or when the web page has been created, right? Who is the author of this web page, right? Is the web page secured? Some kind of a metadata I need to store, right? To store that metadata, I have around 500 KB of storage are required for a single web page. Got it? Understood, right? So stop me if you're not clear on this, right? So basically what we are saying is we have 5 billion web pages in the world. Okay, right? And each web page might take 2000 or 20k kb of text content, right? The content of that page is like something like this. Plus, along with that, I need to store certain metadata, right? Which is like 500 bytes, right? This is what we are kind of considering or assuming this is what I need to store for each page, okay? Which is like for one page, it is almost, if you see here, I'll show this diagram a little bit. Okay. So, okay. So if you see here, one page required around 250, I mean 2500 bytes. Okay. But we have how many web pages in the world? We have around 5 billion. So 2500 bytes into 5 billion is nothing but the total storage, which is nothing but around 10 petabytes of memory is required in order to store all the information in my database, right? So that's a huge storage. Okay. But we need to plan for that. We need to design for that. Okay. So now we have identified our storage. What is our storage capacity? Okay. Next is traversal time. Hey, how much time I can spend, or how much time I'll spend in crawling a particular web page? On an average, it is 60 milliseconds, right? So it's example, there is a page called ndtv.com, right? Let's take an example, right? 1 second, I'll close this. 1 second, guys. Okay, so let's say there is a page called ndtv.com, right? There's a page called ndtv.com, right? Now I need to ndtv.com, right? So this is the page, right? So I need to scroll this page. I need to scroll and get all the text, not the images, only the text from this page, right? So it took me around 60 milliseconds to scroll or to scroll and get the information, right? So that's my average time taken for a particular web pages, which means that now I need to, what is the assumption? There are 5 billion web pages. So 5 billion into, what is that? 60 milliseconds is nothing but around close to 10 years. So it will take 10 years for me to scroll the entire internet and get all the content in store and save it in my memory. Okay. But your business will not wait for 10 years to have that information. You're with me, right? So far, right? So what we need all this information, all the crawling to be completed in a 1 day. Okay. That's what your business says that. Okay. So basically 10 years is nothing but how many days it is? 10 into 365, right? Or 9.5 years here. 9.5 into 365 is around like 3,500 days. Okay. Now what I'm saying is I need approximately close to 350 3,500 servers, sorry, 3,500 servers to complete the crawling of the entire web pages in the world. Okay, so this is what the traversal time, or this is what I have identified. What I have identified, in order to meet our business need, I need at least 3,500 servers, which will be kind of crawling against all the web pages and getting the information and populating my metadata. Okay, and of course, bandwidth also we have identified. What is the bandwidth, right? Like internet, via internet we are getting the information and storing in our database, right? So there is a data transfer. How much of bandwidth I need, those things have been identified as well, right? Total bandwidth I required is this is the total bytes we are trying to end up transferring it, right? So per second, like per day, how much of data we are kind of consuming, right? Like this is what we have, 960 GB per second. Per second, this much of data is being retrieved. But we have more servers now, so we have done this bandwidth calculations as well. Okay, so for I hope you got the understanding. We talked about functional requirements, we talked about non-functional requirements, we talked about capacity planning, what is required on the storage side, or what is required on the servers, number of servers required, right? And also what is the bandwidth we need. Okay, so these are the initial steps we kind of take care for any system design specific functionality. Okay, okay, I'll see if there are any questions. In which form to store the crawling data and determine the right content. Yeah, maybe we'll talk about that as a part of indexing, Jay Prakash, right? We'll talk about what is how the data is being stored and uh, what is the logic we use, right? That will be covered as a part of our indexing in the next slides. Okay, but I'll stop here to see if there are any questions around these concepts, right? Hope everything looks good. So far, you guys are with me.
I have a question.
Sure, Arun.
So what happens when, let's say, some of the web pages get updated?
Yeah.
Does the information that has been crawled before, doesn't it become stale, and how does that updation
Sure.
happen?
Cool. That, yeah, I think is a very valid question, right? So that's where if you see our functional requirement, right? There is a functional requirement called scheduling. Okay. So what is the business is asking is, hey, there are web pages who is getting updated very frequently. All right. You need to have a logic to recall those pages again and again. Okay, right? This is a functional requirement. You need to design for that, right? So there is a concept called URL fortinier or priority queue. We will talk about that in our next slide, right? What exactly is that? I am hoping your question will be answered there. But there is a requirement, right? Like we requirement to recall to get the latest fresh content from a particular web page, right? We need to design for that as well.
Okay. Okay.
Okay, so as of now, we kind of talked about only the ask here. What is the functional requirement? What are the non-functional requirements you have identified? And what is the storage you required? What is the bandwidth you required, right? We have not discussed about the system design. We'll do that in the next slide. Okay, okay, fine. So now, based on whatever we have analyzed, right? So based on whatever we have kind of analyzed, based on our functional, non-functional requirement and our design principles, but we need to identify an architectural style, right? So if you go back, so I have a scalability requirement, or a scalability is one of our architectural characteristics which we have identified, meaning your system should be scalable to add more component, more aspects, and also extendable, right? It need to support new functionality quickly. Okay, so I think the microservice architecture goes well with these aspects, right? Scalability is being supported very nicely in microservice architectural style, and also it is extendable. I can add new functionalities easily with the microservice architectural style, and also this is modern, right? Modern, when I say modern, this is like a this architecture is like a cloud ready. Okay, I think that is also one of our principle or one of our ask, right? So considering these aspects, I was kind of thinking about leveraging the microservice kind of an architectural paradigm here. Okay, fine. So now what we have done, we have identified the important exercise, which is what is our architectural style, which is nothing but the microservice is our architectural style. We are using this here, right? Okay. Again, so there is no, each and every architectural style has any trade-offs, right? Here I have chosen an microservice architectural style, but let's say you don't have enough money. Microservice is little costly, right? You don't have enough money to implement a microservice architectural style, right? Based on the cost, maybe you can go with a monolithic architecture as well, right? It might also work, but it may not be as scalable as microservices, right? So since because of the cost, you might have used to, you determine to go back to the monolithic architecture, right? So again, each and every architecture has a trade-offs. We can't say that this is only the right architecture for a given problem statement. Okay, so based on the permutations, based on the conditions, we will determine. Okay, here in my case, it is Google is not worried about the cost, right? So they are okay to spend more money or invest more money. So that's the reason I am preferring to go with microservice architectural style here. Okay.
So I have a question, sir.
Awesome.
So how do we decide which architecture? For example, so if you're building an e-commerce site, it's not probably getting data from internet, but the products listed in there. So these kind of things would go for a monolithic. Like, how do we decide for this?
So yeah, so there was a session which I kind of talked earlier. There's something called software fundamentals, right? Software architectural fundamentals, right? So basically, predominantly, uh, there is a kind of a cheat sheet. Maybe I'm not sure if I have it handy. Let me try to pull that. Give me a second, right? So there is a cheat sheet which we kind of create to identify what are the characteristics of a particular architecture. Okay, yeah, I may not have it handy. Okay, 1 second. Let me try one more time. Yeah. So this is a kind of a session which I kind of talked about on the architectural fundamentals, right? So here, this is where we kind of talk about what are the various architectural styles we have in the market. Okay. Example, these are the various architectural styles. We have a monolithic, under monolithic, we have these kind of architectural style. In the distributed world, these are the architectural styles we have it, right? So which one to choose, right? So if you example, if you see here for the layer-based architecture, right, or monolithic layer-based architecture, these are the characteristics. If you see here, the scalability is very bad. It cannot scale because everything has been dumped into one particular JVM or a particular instance or a virtual machine, right? So these are the ratings or these are the stars which we have identified for a given architecture, right? Like that pipeline architecture, right? We have identified the set of stars for that, right? Microkernel architecture, what scalability is bad again here, right? But the cost is small here, right? I mean, meaning we can implement a product with a less cost, right? By using the microkernel architecture, but it has its trade-offs. It cannot be scalable. If more number of users are being added, it cannot be scalable, right? So like that, we have discussed this, right? I think it is there in our Expertifie portal as well. I would recommend you to kind of go over that. But if you go back here, the microservice architectural style here, right? So what it has is it has more support for scalability, right? How scalability has been supported. Microservices works on decoupled architecture or a loosely coupled architecture where each and every component running individually, right? So the individual component can scale, right? Maybe we might go out of our topic, right? Yeah, but this is what we have identified. So now I'm referring back to this cheat sheet and I see that scalability goes well with the microservices and our ask here is scalability. So hence I have preferred microservices here.
Thank you, sir. So the recording is also there in the site?
Yes. I would request you to go over the Expertifie portal. I think all these recordings are available there as well.
Great. Thank you.
Or you can reach out to the Expertifie admin guys, so they will help you.
Sure. Thank you.
Good. Okay, coming back to our main topic. Okay. Fine. I think so far you're good, right? So far we have identified the functional, non-functional, all these things. Now we'll go to the system design. We'll talk about the important concepts and fundamentals of the web crawler. Okay. Fine. Cool. Okay. So yeah. So now I believe we will be talking about various concepts, right? So we will be discussing about all aspects of the web crawler. Okay. So we discussed about seed URLs, correct? So that's the starting point. So let's say an admin, in this case, your business owner or your product owner, he is kind of telling you what is the scope, what are the websites, or what are the data sources we need to we need to crawl, right? So that's nothing but the seed URLs. Okay. Example, he might be saying maybe initially as a MVP, most viable product, we might say that, hey, we want to scroll something only these websites. As an example, I'm saying, right? Okay. Only these websites. Okay. What does it mean is, hey, we will, our crawler will only crawl on these web pages to get the information. Okay. So these are nothing but a seed URLs. All right. Now we are building a system like a Google kind of a Google search kind of a system. Okay. So what is our seed URLs here? The seed URLs is the entire internet. Again, the internet as well. There are a lot of websites which is not been maintained properly. There are a lot of websites which is not secure enough, where we are not authorized to access it because of security and all those things, right? So maybe you're maybe after doing some kind of a research, we have identified by automated way, we have identified around 60% of our internet can be crawled, right? So now the Google considers only 60% or 70% of our all the web pages available in the internet can be crawled. Okay, so these are nothing but the seed URLs. Okay, so by some means we have added this database, this seed URLs are been updated. Okay, fine. So we have a list of URLs here. Let's say for simplicity, it is amazon.com, whatever we talked about, right? So these three websites, right, is what we have identified. This is what, as a simplicity, for only just for an explanation point of view, right? So these are our seed URLs. Okay, fine. So the seed URLs are been there, right? So this has been populated in our database. Okay, we have a scheduler. Let's say for simplicity, some kind of a quad scheduler or some kind of a cron tab or some kind of a control M, some kind of a third-party scheduler, we are using it. What this scheduler will do, here you have written a scheduler saying that, hey, please run this scheduler for every 1 minute, right? Some kind of a cron expression we are using and saying that run this for every 60 minutes or 60 seconds, run this scheduler. Okay, fine. So let's assume, right? So we now are, yeah, okay, got it, right? So first admin is populating the seed URL and we have a scheduler in place. Scheduler is scheduled to execute or read this seed URLs and crawl these web pages and get the information, right? On top of that, you have something called priority queue. Okay, or sometimes in the search world, this is called URL front end. Guys, if you're not talking, please be on mute. Okay, cool. Thank you. Right. So this is apart from that, we have a priority queue as well, right? We will talk about that. I think Aruna, I guess you have a question. Hey, a particular websites get updated very frequently. How we can handle that? Okay. So let's say there is a website called Amazon.com where the products are being added very frequently. The products the e-com products are being added very frequently, right? How are, let's add Twitter as well here, right? So Twitter is very dynamic in nature, where people are tweeting about particular news or particular trend very frequently. Okay, how I need to take care of that, right? The frequency of crawling Twitter should be higher. Okay, that's where we have this concept called priority queue, right? What we'll be doing is, we will be, example, Twitter, we have identified the Twitter rank, page rank might be higher, right? The rank of Twitter is higher because the frequency of usage might be little higher than these three websites. I'm just assuming that, right? It is more, I mean, the frequency of data getting populated is higher, the frequency of visitors is higher, so, and the number of words are higher, right? Based on that, I have given the ranking. How we have given the ranking? The ranking has been provided on these parameters. Freshness, okay, Twitter is having fresh data every second someone is adding, or every millisecond someone is adding, right? Based on the freshness, we are giving a ranking, right? And based on the words, right? On Twitter, a lot of tweets are there, the number of words are more, right? Based on the number of words, we are providing the ranking, right? And also based on the visitors, number of visitors, right? So the people visit Twitter a lot, than assuming than Microsoft.com or than Amazon.com or Google.com. Let's say assuming, right? So with that assumption, right, with these parameters, we have given rank as number 1 to Twitter. Okay, what does it mean is, hey, we are always giving a priority to the Twitter. Okay, so somewhere in the priority queue, right, this will be added. What does it mean is, how it just to explain, right, how it happens is, let's say someone is DQ the request from this queue, right? Let's say we want to crawl twitter.com, so that request has been removed from this queue, right? Now we have kind of what you call crawl the Twitter, got the contents, and then again we're adding Twitter again into this queue, right? So we have just done the work of Twitter, right? We got the information, but the rank of Twitter is high. So again, we are encoding or enqueuing the Twitter, recall the Twitter in this queue, right? So that kind of a logic, it works, right? That is an algorithm. It's a complex algorithm where the search engines will use, right, on how to prioritize a particular page to recrawl. Okay, but basically what we're trying to convey here is the data structure here. The data structure we are using is a kind of a priority queue here, right, which will have a list of URLs or list of seed URLs that need to be scrolled again and again. Okay, fine. Okay, so this is a scheduler which is identifying what are the URLs I need to kind of crawl. Okay, so now let's say we have identified some X number of URLs, right? I'm using APIs here. So what I'm giving is, I'm giving that X number of URLs to my gateway, to my some kind of an orchestration layer. Okay, list of X URLs are being provided to this guy. Okay, what we are doing, we are providing that list of URLs to the API gateway, right? This is acting as an orchestrator or a choreographer layer. It is kind of orchestrating, hey, I need to do this, I need to do this, I need to do this, right? That's a choreographing or orchestration logic. Okay, let's assume, for simplicity, for an explanation purpose, let's assume I got just one URL, just to explain, right? I got twitter.com, right? So someone say that, hey, you need to crawl twitter.com. Okay, what it happens, it comes to the gateway. So now the gateway, what it will do is, as a first step, it will go to my DNS resolver. Okay, what is that DNS resolver? For twitter.com, what is the IP address, right? Basically, how we can connect via the IP addresses, right? Like for the given host twitter.com, I need to access the IP address and I need to connect to that web publication and get the information, right? Typically, if you're accessing the internet, when you're accessing twitter.com on your browser, right? The same DNS resolving will be taken care of by your ISP provider. Example, if you're using an Airtel, Airtel will take care of that, resolving twitter.com to the respective IP addresses, right? Again, that's out of scope, but in order to speed up the process, what we are doing is we are implementing a custom DNS resolver. Okay, what this DNS resolver will do, this is a private custom DNS resolver. This DNS resolver will give me the IP address for a given host. Okay, step number one, we are going to the DNS resolver and identifying the IP address. Okay, now I got the IP address for twitter.com. So using that IP address, I'm calling the HTML fetcher. What this guy will be doing, it will be accessing that twitter.com, I mean via the IP address, right? And getting all the information specific to twitter.com, right? That's the HTML fetcher. Okay, it has fetched me the text, right? Example, in the twitter.com, there is, for simplicity, let's say there is information called hello world. That is one tweet is there, right? And there is some more ABC, something like that, right? So these are the two words which we have captured from the twitter.com, right? So that information, right, is been given to the extractor. Okay, but we will talk about that in detail. Okay, understood, right? So in a twitter.com, you have access the twitter.com via the HTTP fetcher. The HTTP fetcher was able to get all the content. Along with the content, it is also able to identify the sub URLs and the sublinks. Meaning in the twitter.com, if you click here, there will be something like twitter.com/about us, right? Something like that might be there, right? Or it might have one more hyperlink called twitter.com/carriers, right? Or contact us. Various hyperlinks are there. So I am just in the home page, but I have identified there are multiple sub pages as well, correct? So these sub pages, what we will be doing is, as soon as we identify the sub pages, we will add those sub pages into the priority queue. Understood? I'll repeat it again, right? So what we had twitter.com. Okay, so we have accessed the twitter.com, right? So the request was to crawl the twitter.com. So the scheduler has sent that request. So we are able to get the IP address of the twitter.com, right? And we are able to fetch the content of the twitter.com. Now in the twitter.com, we have identified there are sub URLs, about us and carrier. Okay, what we'll do, I need to crawl these sub URLs as well. What I'll do is I'll add these sub URLs into my priority queue. Okay, I'm somehow, I mean, I did not mention here, the arrow symbol was not there, but basically the HTML fetcher, right, will add the sub URL details into my the priority queue. Hey, twitter.com is not about only the home page, right? Okay, maybe hope you're able to visualize, right? So basically what we are doing is we are adding in the priority queue, we are adding, you need to scroll about us as well as the career.com as well, right? So these information is been added in this priority queue. What does it mean? So now in the next process, it will crawl the about us and it will crawl the career pages and get the information for us, right? Which we can use in our search functionality. Okay, fine. So for simplicity, let's say there is no other sub pages, right? Twitter.com is just a static page. It has some hello world, hello to Twitter, something like that, right? So that information we kind of captured, right? And we are putting it in a as one of our principle is we want to process asynchronously, right? If you see here, one of our processes process asynchronously. What we are saying is, hey, I'll put it into some kind of a queue or some kind of a Kafka in our case, right? So that things can be processed asynchronously. So I have whatever available content like hello world, that information is being kept in the queue, right? So now we have a set of processes in place. Okay, one is extractor. Now what this guy will be doing, it is nothing but identifying all the list of tokens. When I say tokens, hello world, two tokens are there. Hello is one token, word is one token. So that is the purpose of this extractor. It will identify all the tokens in a given page. Okay, got it? Right. Next is duplicate finder. Okay. Hey, is it duplicate? Already I might have uh, processed the twitter.com and the content looks exactly the same. Is it the duplicate content? If yes, there is no changes, right? I mean, the page has not refreshed, something like that, right? If there is a duplicate data, maybe I can do some normalization and all that, right? So that's a one more process we'll be doing it. That's a duplicate finder. Okay. Next is the stop words and stemming and limitation. Maybe I'll take an example to explain these concepts, right? But before that, any questions? Anshu, okay. Okay. Anshu, can you please throw some light on crawling done as an anonymous user as an authenticated user? Okay. So typically it is crawling is done uh, either it could be done in both the ways, as a anonymous user as well as an authenticated user. It all depends on the case by case. So typically if you crawl, if you example, if Google is crawling, right? So Google will send a request to twitter.com with a user agent in the browser, or if you know, right, whenever you're accessing a web page, example, when I'm accessing, right, if I see the page source, right, so there will be something called an user agent. Somewhere on the top, you will be having the user agent as well. Yeah, if you see here, right, so there is some details around the user agent. Okay. Okay, fine. Basically, the user agent in our case, it will be the browser. It will say that who is accessing this? This has been accessed by the browser called Edge. In my case, I'm using Microsoft Edge. So the Edge is using the are accessing these things, right? When the Google is doing that crawling, what they'll say is, I think they have something like Google Agent, something like that is there, right? So this will tell the website to twitter.com who is doing it, right? Whether it is done by the robo or whether it has been done by the user or whether it has been done by Google agent, right? Maybe based on this user agent, these websites can access certain logic as well, certain authentication principles or certain conditions as well, or they might streamline their content based on the user agent as well, right? But yeah, back to your question. Typically, the public websites like google.com or Bing search will work anonymous. User will access the content directly as a normal without any credentials, right? But they might pass certain user agent details or HTTP metadata information to the websites like twitter.com, right? Of course, if required, there might be some confidential websites, right? Example, let's say in our use case where we talked about crawling our HR web pages, right? HR is a kind of a confidential information, right? So in order to crawl, also you need to have a right permissions, right? In that cases, in those scenarios, maybe you need to crawl via certain credentials, right? So based on the credentials only, these guys will authorize to access your web page, access your portal and get the information. Okay, it all depends on context to context. It is a subject to answer, I would say, right? Based on the use cases, the respect to authorization mechanism will be applicable, whether we need a user credentials or it can be done anonymous. Hope I have answered your question. Yeah, cool. Great. Yeah, coming back to our topic, right? Okay, fine. Okay, so yeah, the crawl, I think we got small tokens like hello world from twitter.com. So we have extracted the tokens and we have done some duplicate check, right? If there are duplicate worlds, duplicate things or not, right? After that, we have some more processes, right? I think these are little important concepts which I'll take an example and then talk about that, right? Okay. I'll take an example, direct example, maybe. Okay, maybe, yeah, we'll talk about indexing as well, but yeah, I'll take an example. Prithviraj Chauhan, will Google search, Twitter search results, same set of information? I mean, Google search is having its own logic algorithm. Twitter search has its own logic and algorithm, right? Both are operating in a different way, right? But in the background, everyone is using the three components, right? Like crawling, which is aggregating the information, right? In this case, Twitter might be aggregating the information from its own database, whereas Google is aggregating information from multiple web pages, right? And you have indexer. Twitter has its own indexing logic. Google might have its own indexing logic, and query results, right? Twitter has its own logic. Google has its own logic. Okay, fine. Okay, so to explain the functionality about certain concepts like stop word and yeah, stop and stemming, right? I'll take an example, right? For simplicity, of course, this I might talk about the same concepts during the indexing as well, but let's take an example. Let's take, there are 3 documents, right? And we have crawled our, in our seed URL, hope you remember what is seed URL, right? In the seed URL, someone mentioned that, hey, we need to crawl only these 3 pages. Okay, got it? Seed URL has only, the seed database has that, hey, you need to crawl only these 3 pages. Okay, so this is what our source is, right? And if you see here, each and every document has this set of information. Okay, right? So now what I'm doing, I'm crawling each of this page. Okay, let's say I have crawled page number 1. Okay, how many tokens I have? Let's go back to our architecture and see, right? Okay, I have crawled page number 1, right? So page number 1, the crawling has been done. So what is there in our page number 1? Let's write as well, right? So page number 1, we have open search. Open search is a search. Okay, is a search and analytical suite. Okay, so this is what, let's say this is a website which we are, this is a document, our website or a web page where we have crawled and we have identified these are the kind of a things. Okay, right? So HTML fetcher has given that information to me and I'm giving it to the extractor. What the extractor will do, extractor will tokenize this into small tokens. What is that? Open search is 1 token, ease is a 1 token, a is 1 token, search is 1 token, right? And is 1 token, analytical is 1 token, right? And the suit is 1 token. So this is what the extractor has done for us, tokenization, right? That's what the extractor has done. Okay. Now, if you see here, right? So is, a, the, and this does not make any meaning to us, right? These are very common in English language. If you see here, the is, right? A, the, right? It does not have any meaning. It is subject to, it provides meaning based on the subject, right? Okay, and right. These are not required for me to focus on, right? These are, maybe if I search for end, I may not show, I'm not required to show this particular document. Even the end is available in this document, I'm not required to show this document, right? Because these are very common. If I search for end, almost every document in the world will have that end as a word, right? So I want to ignore some of these words, right? So these are nothing but, we consider it as a stop words. Hey, I don't want to consider these words, right? These does not have any generic meaning. It is dependent on the context about the document, right? So here in our use case, is, a, the, and end are the stop words. Okay, most of the lot of third parties are available in the market which are third-party libraries or tools available in the market, which will give you certain predefined stop words. Okay, companies like Google build their own stop word, right? And I think they might have exposed their stop word library as well, right? When you're building your own search engine, maybe you can use that library as well. But what we are saying is, in our case, we don't need, I mean, in our case, these are the stop words, right? I don't need to focus on the words like is, ye, and. These are very common in English language. Every document will have that. And that meaning about this word is subject to the particular document or a particular context. Okay, so these are the stop words, right? So if you see here, what I'm doing is I'm ignoring that stop words. Okay, so coming back to our architecture, what is the stop words? Stop words is the guy who is removing certain words which are not required for indexing. Okay, that's the step of a stop words. So coming back to our case here, when you are crawling the page number 1, okay, we have identified open search, right? What we have done is open search. We have kept it in a particular table. Okay, we'll talk about this. This is kind of a term table. Hey, open search. Okay, it is there in the document number 1. That's what I'm saying. Okay, fine. Right. Next is I'm not is a stop word for me. A is a stop word for me. I'm not storing them in the indexes. So what I'm doing, search, okay, is a valid. It has some meaning. It has some prominence. So what I've added, search in the document number 1. Of course, I'm adding a frequency as well. Okay, frequency. How many times this document is available, right? In this page number 1. All those things have been added. We'll talk about that in detail when we discuss about indexing, right? But what I kind of I want to convey here is only the important keywords or important tokens are required to be indexed. Certain keywords like is, a, and the can be ignored, right? Those are the stop words, right? That's what the stop words logic is all about. Okay, so that's the concept of stop words, right? There are open source libraries which we can leverage as well. Okay, fine. So the next is stemming and limitation, right? What exactly is this, right? What is stemming, right? So example, maybe I'll take an example, right? Let's take an example, right? I have search. Okay, I have searching, I have searchable, right? I have something like search. Yeah, so these are the words, right? So these are the words in a particular document. So in our case, I don't think we have an example, but let's say the word is like open search is search and searching, something like that, right? So if you see, there is some kind of a prefix has been added, right? Right. So our intent was, if someone search for, let's say this is available in document number 1, this is available in document number 2, and this is available in document number 3, right? If someone search for search as a text in the Google search box, right, we need to show all these 3 things. Okay, so that's the process of stemming. Stemming is a process, or it is having certain algorithms. We have some certain stemming algorithms to identify what is the core bucket. In this case, the core bucket for us was search, right? Meaning here we have realized that, hey, this falls under searching can be shown when someone search for when someone kind of query for search, right? Searchable can be accessed when someone is searching for or someone is querying for search, right? So basically, this process of stemming is identifying what are the prefixes and suffixes, and maybe those can be based on the context. Maybe we can classify what is the keyword. Okay, meaning, let's say this is what we have. This is the word we have in our document number 1, right? So if you go back to our table, so now I'll say that search frequency is 2, because logically I think search is same and searching is also same. Okay, so I will, when someone click on search, right, maybe I'll show, I'll say the frequency is 2, meaning you have 2 times the search is there in this document. Okay, so the concept of stemming is to kind of, it's a very generalized statement. It's not the right statement. I would say stemming is a big concept again, right? The concept of stemming is identifying a relatable keyword, right, by removing the prefixes or by removing the suffixes, right? That's the concept of stemming. Okay, hope it is clear, right? And we kind of talked about one more concept. Okay, what is this, right? Again, this is also based on the context. Example, in India, we call petrol station, right? This is the petrol station where we can get the petrol or diesel or whatever it is, right? Whereas in US, they might call it as gas station. Okay, right? So basically, based on the, what you call, based on the um, location or based on the culture or based on various aspects, we might need to understand the context, right? If let's say there is a website, let's say there is a website called Indian oil petrol something like that, right? So they went to US, right? So they started their what you call, their branches in US, right? So if some customer in US tries to search for gas station, we need to show this guy, right? Basically here what we're doing is, again, it depends on context to context. What we're doing is we are categorizing petrol and gas as same here in this context, right? So hence, when someone search for gas, we show Indian oil petrol pump address information, right? So this is the concept of lemmatization. Okay, again, lot of algorithms are there, lot of logic is there around this, right? But basically here the concept is to identify the relatable terms or identify the synonyms and do the indexing accordingly. Okay, understood? Stop here. I'll stop here to see if there are any questions. Okay, fine. Fine. Okay, so what we are doing here, so this is the list of steps we are doing it. After extracting something from the twitter.com, right? Okay, what we have done, we have tokenized it. We have identifying if there are any duplicates, right? If yes, remove that duplicates. We are executing against the stop words. What is stop words, right? They remove the words which are not having any importance or any relevance, like is, the, a, all that. And then we are going over the stemming and legitimization to identify the synonyms or removing the prefixes and suffixes, right? Again, that's a generalized statement. There's a huge topic here. Maybe if we can talk about, again, I'm not expertise in this, but people can talk on this concept for hours, right? There are a lot of algorithms around stemming and lemmatization. Okay, after that, what we'll be doing is we will be storing the metadata or the content or the text uh, in our database, right? This is how it will be doing it, right? So if you see here, after crawling all these 3 documents, this is what we are storing. If you see here, the open search is there in all the 3 pages. Okay, that's the reason open search is mentioned in page number 1, page number 2, and page number 3, or document number 1, 2, and 3, right? And what is the frequency? If you see here, page number 1, the frequency is 1. Okay, only one time I have the open search. In the page number 2, I have the frequency is 1. We are maintaining that as well, right? And the page number 3, right? Also, if you see, the number of times the open search is there is 3 times. Okay, so this is what we were doing it. This is the information we are trying to save in our database. The table, whatever we talked about here, the big table, this is the information that is being saved after crawling all these documents, right? So this is the area where Google was very successful, right? In order to store this kind of information, they have introduced the concept or introduced something called big table, Google's big table, right? I think that's where I think they were little famous as well on scalability perspective. I'll stop here to see if there are any questions. Abhishek, if you mark some words as synonyms and in some other context are not actually synonyms, how do again it depends on Abhishek? Yeah, the answer is it depends on the document or the uh, web page which you are kind of scrolling, right? This is lot of AI algorithms, lot of logic is there to identify which is synonym, which is related. If a web page talks about, let's say, petrol or gas, maybe that is more uh, applicable to replace petrol with a gas as a synonym, right? But let's say there is a page which talks about three states of a matter, which is liquids, gases, and solid, right? There the context is different, right? Hope you are able to get the context here. It is all subjective, right?
Yeah.
So based on the page, if the web page says that, hey, this is the three states of matter, right? Which we used to study in our schools, right? Three states, right? What are the three states? Maybe it says that hey, we have three states of matter, which is solids, liquids, and gas, right? Okay, so here the context is different, right? Okay, whereas here the gas mean in different context. Whereas let's say there is another web page which talks about petrol prices, right? So here the context, when you say gas here, maybe the context is a little different, right? So based on the context, we might need to determine what synonyms you need to apply. It is a subjective, right? Lot of algorithms are there to identify the subject, right? Maybe it is out of our scope for now. Okay, hope I have answered your question, Abhishek, right? And Hemant, are there any drawbacks of storing the documents like this? The matrix very big from use. Exactly, right, Hemant? That's the thing. Maintaining this matrix for, we are talking about 3 pages, but in the world we have 5 billion web pages, correct? So we need to maintain this kind of a matrix. How we can maintain this matrix, right? How to store these things is being taken care, are being addressed by various other algorithms. I would say, if you have an interest, go and check B-tree, right? So B-tree is a data structure which is leveraged by these search algorithms to store this kind of a huge matrix, right? By the way, this is called inverted index. We'll talk in detail again, right? This is called inverted index. How we can store this inverted index, or how we can maintain this kind of a data store, is again a big concept. The data structure which people generally use is B tree or B plus trees. A lot of concepts around this, right? And of course, the Google organizations, they came up with something called big table, which is a denormalized data, right? Maybe talking about big data is big table or big data is a bigger concept. Here, that's where the concepts like Hadoop, right, and various other big data platforms will come in place, right? That's where the big data structures or big data specific tools are being popular, right? Hope I have answered your question, Hemant, right? And Prithviraj, okay, we hear Google algorithm changes every day. Does it means that? Yes, that's right, Prithviraj. Yeah, they change their algorithms every day, right? So so today, if you see here, right, the extractor, the algorithm could be changed. Maybe because they're adding a new languages, they are learning something new, they might change the algorithms again. Duplicate finder, hey, they might realize that something is bad, they might change their logic or their algorithm around duplicate finder. Stemming and legitimization, right? So they have realized something went wrong. right? They might change their algorithms. Or stop words, they might change their algorithms based on certain criteria on daily basis, right? So if you see here, the process which we are talking about here, these are very dynamic in nature. The algorithms need to be changed dynamically, right? The machine should learn uh, based on its data and need to improvise their algorithms, right? Yeah, I don't, I'll not be surprised if Google says that, hey, we change the algorithm for every 1 hour. It is possible because of the dynamic nature what we see here. Okay. Okay. Yeah, we need to, because we need to need an estimation of index table. So yeah, so that's what we have done, Vikas, right? So if you see, right, what we have done the estimation, right? Estimation of the storage. We need to store this much of data in our index table. That's the activity which we have done. 5 billion pages, this much of data, how much data storage we need, right? The total storage is, this is the petabytes of memory is what we required in order to store all this information. Okay, so this is what the effort we made in order to identify the storage capacity. Okay, fine. Yeah,
Sir, you mean like 2K, 2KB is a text actually for each, from each page,
page,
or
right?
something like,
yeah, so that's
have,
what, right?
So it has 1 characters.
Yeah, so that's what our assumption, right? So based on certain study, based on certain analysis, we identified that each, on an average, each web page might have a text content which is around 2000 KB. Along with that, we need to store the metadata, right? Along with that, we need to store certain metadata about the web page, right? So this is what the estimation. Again, these are like a ballpark estimate only. These are not the exact estimates. Based on certain analysis, we came up with this storage capacity, right? But if you learn that, hey, we need more than this, then yeah, we need to increase the storage capacity here. That's the capability the microservice architectural style provides, right? You can add more instances of DB storage here, or more instances of the servers here. Okay, so when I say the scalability aspect, right? So example, we see that, hey, we need a lot of instances to process the stop words, right? Right, because stop words, lot of web pages, stop words processing need to be faster, right? Maybe we can add just the number of stop word instances, right? So that processing or ignoring the stop words can be achieved in a much better way. So this is the advantages of going with the modular approach or a decoupled architecture. Okay, right? On the same, yeah, on the same lines, if you want to scale the stemming logic, we can add more instances of stemming logic, right? So that it can take care of more stemming algorithms. Maybe this guy will run the stemming algorithm A, this guy will be running stemming algorithm B, something like that, right? So those can be done. So by doing this modularization or breaking down or decoupling the application, we are achieving the functionality of scalability. Okay, right? And again, here for simplicity, I mentioned this as a sequential steps, but this can happen parallelly as well. Meaning, all this can run parallelly as well, right? It all depends on how you want to design. For simplicity, I made it as sequential, but all these things can run parallelly, right? That's where I think you can think about various integration patterns. Maybe if you don't have it, I would ask you to kind of enterprise integration patterns, right? This is a very good book, right? I would recommend you to go over that, or at least you can go over these various integration styles, right? Example, so if you want to do a parallel sequential processes, what is the pattern you need to use, right? If you want to use various parallel processing, what is the pattern you need to use, right? Various integration patterns are there. Maybe you can think about that. This is something like a integration pattern to achieve the parallel concurrency pattern, right? Yeah, I'll ask you guys to take over or kind of read about these integration patterns offline. Okay, fine. So I assume at a high level, you got the context about what exactly we are doing as a part of our crawling functionality, right? Basically, crawling is nothing but we have a seed URLs, okay? We have a scheduler which will read these seed URLs, access the URLs, get the content, and do certain normalization. The normalization is nothing but extracting, identifying the duplicates, applying the stemming logic, applying the stopwords logic, and populate the metadata or the table which can be used for searching. Okay, cool. Okay, cool, great. Okay, so this is the crawling functionality, right? I assume you got a good understanding about crawling, right? Of course, we will share all these presentations to you guys, right? I need to do some cleanups here, but yeah, I'll be sharing these presentations as well as this recording to you, right? Okay, fine, right? So now we have the data in our database, right? In our metadata, we have the database. Okay, so all the information has been available. Going back to our important concept of this guy, right? We are able to populate, right? We are able to crawl the information. On top of that, we have added indexes, whatever we have shown you, right? This is kind of an indexes, right? Kind of maintaining this kind of a matrix, right? A big matrix, right? Where it will tell you what is the documents and all, right? Means a particular keyword is available in which document and all, right? And now the metadata has been available. Basically, you have this matrix available. Okay. Now, as a customer, you are querying, you are searching, right? Okay. What you will be doing? You will be querying against this metadata. Okay. Example, someone says that, hey, I want to identify the licensed. Okay. I am searching for a licensed, meaning when I say searching, let's say google.com only. Okay. So in the Google search, I have searched licensed. Okay. Licensed, right? So this is what I am searching it basically. Okay, fine, right? So this is the keyword which I am searching. Okay, now what it will do, this is nothing but what we are doing, we are asking is querying. We are querying against our search functionality. So what this guy will be doing, this will access against this particular matrix, right? So here it is being indexed. So basically when I say index, it is a random access. Directly I can see, hey, where is the licensed? Licensed is there in this particular guy, right? What is that particular guy? Document number 2, right? What the response it will show, a licensed is available in this particular document, right? This is what basically the results here is nothing but a document 2, assuming this is a document 2, right? So we are showing the document 2 here. Okay, so that's how the search functionality will work, right? So the concept of indexing is what we will be talking about here is, here the index are most of the search algorithms or most of the search engines use an index called inverted search. Okay, that's what we will be spending some time to talk about, the inverted index. Sorry, no, I did mention as inverted search. Sorry for that. It is inverted index. Okay, what is inverted index? Inverted index is one of the most popular index mechanism used in document retrieval, right? So we know we learned arrays, we learned lists and all that data structures, right? Which is using a very basic indexing, right? On the same lines, we have something called inverted index. This is used in document retrieval. Okay, right? So what it does, it enables the efficient implementation of Boolean, extended Boolean, proximity, ranking, relevance, functionality. So meaning on top of identifying the keywords, it can help or it can apply certain other aspects as well. Proximity. If you are searching in from India, maybe based on your location, we can apply certain algorithm to retrieve from which pages. Maybe we will fetch it from Indian specific web pages, something like that, right? Or we will be leveraging the page rank. All those things can be applied on this index inverted search data structure. Okay, advantages I did mention here, right? Of course, the disadvantages, as someone mentioned, hey, we need to maintain a huge matrix. Here we're talking about, here this picture talks about only 3 pages, but in the world we have 5 billion pages. How we are maintaining that 5 billion metrics, right? Of course, we are maintaining that 5 billion metrics by using different data structures or different mechanisms like big table or the data structures like B trees, right? We are kind of maintaining that particular data structure. Okay. Okay, fine. Got it. Okay, fine. Okay, so this is an inverted search. I assume you got the context based on this particular representation, right? So basically, we have parsed or tokenized each and every string in this document, right? And we are trying to maintain this term data or term table, which has frequency and document, right? So there is a concept called term table or a term data, right? So I could not add it in the presentation because I did not get enough time. But basically, you have something called term dictionary, right? What is this term dictionary? Whatever you are seeing here, right? This is nothing but a term dictionary or term matrix, right? Okay. What is the term matrix or term dictionary will have? Term dictionary or term matrix will have these columns. One is the term, right? What is the term? Like open search is one of our term here. Document count, in which documents it is available, right? If you see here, the document count we are kind of capturing in this figure, right? Document count. What are the documents this term is available, right? Document count. Frequencies, we identified the frequencies as well. Positions, right? What is that position? Here again, the position is okay. Where exactly is this document available? I mean, this what do you call this? Maybe this document has n number of pages. Okay, when you're searching for an open search, the open search is there in the document number 1, but in which page? What I mean is, if you see here, I have 3 pages in this video, right? If someone is searching for a Stack workflow, Stack Overflow, okay, this guy position will tell me that, hey, it is there in the document. What is the document? Whatever the document is, the Google document, google.visio, right? Okay, but this term, what is that? That term Stack Overflow is available in the page number 3, right? That is what the position convey here. Okay, got it, right? And then, yeah, there are certain offsets need to be maintained for highlighting and all that, right? Example, if you remember, if you see, if you search for this kind of string, there will be some kind of a highlighters. I'm not sure if it is enabled here, but yellow color highlighters will be there. Or example, if you search for a google.com as well, let's say license, yeah, there will be highlighters. Sometimes it will be highlighted with a yellow color kind of a thing, right? So that's the offset is being used for that highlighting logic. Okay, but yeah, coming back, what we are trying to say is, okay, we are using, okay, I'll stop here. I'll take a 1 minute here. Okay. So what we are trying to convey here is, after crawling, after getting all the data, we are maintaining a metadata. The metadata is nothing but a term dictionary, right? And it will have these kind of information. What is that information? It will have term. It will have the frequency of the term, right? Okay, and it will have the document. Okay, and it will have what is that? What is the term? It will have the position in the document, which position or which within the document, which page I need to go, right? And it will also have some offsets, right? So this is the kind of information which we are storing it in our matrix or the big table. Okay, so predominantly all the keywords in the English will be available in the term, starting from ABC, right, to almost all the words, right? There was some kind of a mention that there will be something around million English keywords or something, right? So it is not a challenging for companies like Google to maintain a million rows in this database. Got it, right? So we are storing a million rows, right, in this database, right? And we will be kind of identifying what is the document, right? For example, there's a word ABC. This might be there in multiple documents. Document one, when it's a document, it could be a web page, right? It's like 1.html. It might be there in 1.html, 2.html, 3.html, like that, n number of pages, right? How they maintain in a binary form, like example, let's say in our example only, right? Okay, so open search. I'll take this open search, right? So this is there in document 1, 2, 3 in our example, right? So they'll not maintain the document 1, 2, 3, right? What they will be doing is they'll be representing in form of a binary. It might be something like 1, 1, 1. 3 documents, right? First document I have 1, second document I have, so it's 1, third document I have, it is 1, right? Let's say another keyword, let's say search. It is there only in the document number 1. So how they'll maintain is they'll maintain something like 0, 0, 1. A bitwise kind of a thing, right? Maybe, yeah, 0, 0, 0, 0, 1, right? This is how it will be maintained, right? This way the data, is not huge, right? You don't need huge data to store the exact hyperlinks of that web page, right? Using the bitwise operators, using the bit, you're trying to save certain space as well. Okay, so in short, I think maybe in the interest of time, I might go a little quick. In short, what we are doing is we are using the inverted index. Inverted index will look logically, will work like this, right? This is what is being used by most of the search engines. Okay, right? So I hope you got the context. You got the context around the indexing, what we are using in our search engines like Google or Bing or any other search options. Okay, I want to cover one more aspect here, right? One more aspect here is example in the crawling. We have mentioned that we will be using the seed URLs. Always the URLs will be pumped up in our databases, right? Along with that, sometimes we use connectors as well. What does that connectors mean is, I'll take an example, right? Let's say I search for Elon Musk. Okay. Yeah, is right. So I am searching for this particular person, Elon Musk, right? So if you see here, the results is we are directly getting the details from the Twitter. Okay, I just wanted to talk about this business model. So Twitter had an agreement with Google. Okay, Twitter and Google has agreed, right? They had some business agreement. What the business agreement is? Google is paying some amount to Twitter or some money to Twitter, saying that, hey, we want to access against your Twitter directly. Okay, and we'll pay for that, right? So this way, I think the customer experience of the Google users is getting improved, right? And this way, Twitter is getting the money as well, right? Only one of the, I think now Twitter started adding ads and all, but Twitter never used to have an ads earlier. So the source of income for Twitter was only via the Google or via the search engines, right? So now Google is paying some amount to Twitter because we are querying against the Twitter database. So in this case, what happens is, in this case, we will be establishing certain connectors. We will not have the Twitter URL in the seed database, right? But we'll have a Twitter connector. Okay, so there's a Twitter. What this Twitter is doing is Twitter is pushing the information to our metadata. Okay, this is like a connector. One connector we have established. So this guy is pushing an information, right? It's like here we are doing a pull mode, correct? We are pulling the information from various websites, right? We are pulling the information from Amazon.com, pulling the information from Google.com and Microsoft.com and populating our metadata. But here Twitter is pushing the information because there is an agreement, right? So Twitter is pushing the information so that we'll have the latest and greatest information, and our metadata will be populated with the latest content, right? This is one way. This is one kind of a connectors which people might implement in their web applications or in their search requirement, as well as in this use case as well, right? Okay, when you are implementing some kind of a intranet service, maybe you can establish a connector, right? So the tools like ELK or the stack like ELK, Elastic, Log Stack, and Kanban provide some kind of a connectors which will connect to this HR web page and get the information in the real-time basis, right? So this is also one more mechanism which we use in order to crawl or in order to aggregate the information in our metadata. Okay. Yeah, I'll stop here to see if there are any questions. Right. So again, this is a huge topic, right? Lot of concepts, lot of algorithms are there, which we may not able to cover. Example, the algorithms around stemming, algorithms around ranking, all those things we may not able to cover. But what we are trying to do here is explain the concept at a high level, how the search is working or how the Google is implementing their search engine, right? So just to reiterate and summarize, the important components of any search engine is crawler, indexer, and the query or the searching. Okay, I'll go back to our chat to see if there are any questions. Okay. Yeah, okay. Yeah. Yeah, because you might be wrong. I'm not talking about exact business model, but yeah, all I know is they have some kind of a deal, right? Okay. So there was a question from Kamalapriya. Can certain websites be blocked for certain users irrespective of the parameters mentioned? Yes, yeah, all those the logic, what websites can be blocked, everything can be maintained in your logic. That's where I think someone mentioned that the algorithms of Google change on a daily basis, right? During the extraction process as well, you can apply certain filter logic, right? So now I can add a filter logic here, right? What is this filter will do? Filter will do like what websites I can block or what content I can block, what text I can block it as well, right? And of course, in the seed URL as well, you can remove or block certain websites based on certain location as well. All those rules can be managed, right? So basically it is a pipe and a filter integration pattern, right? You can implement whatever you want by adding certain new component in place, right? Okay.